Now then, crew, and welcome back to the Andy Mechanic YouTube channel. This video is all about the idle speed control valve system used on many ATVs. This is a Suzuki. Obviously they have to have fuel injection to have one of these. This is the King Quad 500 2019 vintage, and the idle speed control valve looks like this. This isn't the one off this particular bike. This is a spare one that I've got. No idea if this one actually works or not, but we've got the PicoScope already set up on the bike so we can capture the waveforms from the 4 grounding wires, that'll become clear shortly, between the idle speed control valve's stepper motor and the ECU. A really quick way and not very intrusive at all, to be fair, on checking the condition and the operation of the idle speed control valve. Plus you can give the wires a bit of a wiggle whilst it's operating, and of course if one of those lines drops out, then of course you know that you've got a potentially broken wire somewhere in the loom or a bad connection. Right, let's take a quick look at the Suzuki manual to show you the wiring, then we'll capture some waveforms, and then we're going to have a little look at and how those waveforms relate to each other. Here we go. Used.
You don't paint something without wiping it.
Honestly. So, embedded in the Suzuki manual is obviously various wiring diagrams, and just digging through them we can see on this one the idle speed control valve. Oh geez, come back. There we go, there's the prize. Can we make it bigger? We can. So we've got what's called a 6-wire idle speed control valve. We've got the 2 red with the black tracer, that's RB, and another one RB there. Those essentially are the power feeds. That's 12 volts coming in, that's loom voltage coming in to power the actual actuator. Now we've also got 4 grounding wires. As you can see inside, they've done a great little drawing here actually. I was going to do this myself, but there's no need now. You can see inside there we've got 4 windings. So for example, we've got on this particular diagram, we've got the pink with the white tracer is 1 winding. So the current comes in from the red and black and goes around the winding and out through the pink with the white when the pink and white is grounded. Same goes for the black with the light green, 2nd winding, and they work in pairs, and we'll see that on the scope. And again, we've got the other pair of windings where you've got the power coming in, red and black again, and we've got a green wire as one of the grounds for one of the windings, or the ground for one of the windings, and the other ground, the final one, is white with a blue tracer. Now, to be fair, the colour codes vary a little bit on this particular bike to what's in this service manual. I do know that this manual is not for this year of bike. I think it's the year before. Yeah, I think it's the year before or 2 years before. But the idle speed control valve itself is identical. And this is all about the theory of how they operate and how to test them. Okay, let's take a quick look around how the scope's plumbed into the bike, where I've back probed, and then we'll go on the screen and I'll show you the settings that you need in order to capture those particular waveforms. It's pretty easy really. Here we go. So I've gone in at the actual idle speed control valve. I feel that's very important because it checks the actual wiring in the harness as well. You can also go in at the ECU. It's a little bit congested down there, to be honest, and if you do that, then you're not really testing all the wiring, in all honesty. You're not. Okay, so we've got obviously 4 channels at play today, 1 for each of those windings, and well, you can't really see a lot on there, can you? But you'll have to believe me that the wire color coding on this bike is a little bit different to that in that particular service manual, but it's good enough. It gives us an idea. Now, on the actual plug itself, it's the two center wires. They're red and black. They are the power feeds, but they're not permanent power, and they don't go dead as soon as you turn the ignition off. Actually, if I do that now for you, if you have a little listen, I'll put you really close. So I've got so many wires. Right, if you have a little listen, in fact, I'll get the ignition key in shot as well. There you go, look. Right, ignition on. Doesn't do a lot, obviously. We'll turn it off. There you go. So as you can see, it's still actuating and resetting with the ignition switch in the off position. So there is power for a period of time. We don't know how long yet, but the scope will tell us, from when the ignition's turned off to when it powers down, basically. And obviously the ECU controls all of that. Okay, so because we're basically dealing with a 12-volt system, each channel needs to be set on 20 volts, obviously DC. And as regards to time division, I've gone for 500 milliseconds per division, just up here, look. And that's it. It's really easy. Okay, well, let's take a capture. Okay, start the scope, turn on the ignition, turn off the ignition. Excellent. Okay, let's just go back to the powered down capture. There we go, look. And if I just zoom in, this is what you're going to expect to see. This is a known good, by the way. You will see lots of wiggly lines, as Steve likes to call them, which is very cool. Now, they are in pairs, like I said before, and we saw that in the Suzuki diagram as well, on the wiring diagram. So, if I just separate them out, all will become really, really clear. So we'll leave channels 1, the blue and the red, where they are. Let's just move channel 3 down. And let's move channel 4 down. Hey presto, there we go, look. Okay, now one thing I didn't show you earlier is the grounding lead for the leads for the scope probes is on battery negative. So when we have essentially 0 voltage on, so if we look at the blue waveform first, in fact let's get rid of the red one completely. Let's move that down a little bit. So when we're seeing the 0 volts, i.e. the low point on the waveform, that's when there is current flow through that particular winding. It's been grounded by the ECU on that particular wire. When the voltage bounces up, that's when essentially we've got open circuit on the ground side. So we're seeing battery voltage because basically we've got that input wire going, the red with the black input. The voltage is on the winding, but the winding's not being grounded, so that's why we're seeing that 13 volts. And then of course the ECU will ground it again. Now, being a stepper motor, the ECU has to ground these windings in sequence in order to get the motor's armature to rotate in one direction or the other. So, oh, wrong one, put that back down there again. I need the red one, don't I? There we are. Get the red one. So, like I said before, they operate in pairs. So when I bring the red one up, which is channel 2, which is on the green and red wire, you can see if we start over here, look, at this point in time, the green and red wire is being grounded and there's current flow. And then as soon as that's turned off, i.e. disconnected by the ECU brake circuit, then the white and blue wire, i.e. channel 1, is now being grounded. And then it just repeats it over and over again. Now, offset to that, exactly midway by the looks of it, there you go, look, exactly midway is the other pair of windings. So we've got the green, which is this waveform here, look, and that's currently being grounded, so we've got current flow going through the pink and black wire, and then it switches straight across to the blue and pink wire. So all the time, these windings are being energized in sequence, and that causes the armature to actually rotate. And being a stepper motor, it can very accurately move that armature in very, very small increments. I don't know exactly what the increments are or how many increments there are per rotation. I've never dissected one, you know, or worked it out. But that's basically what's going on. And when you do scope them, you should see that all 4 of the channels have the 12 volts or the battery voltage when it's disconnected, and you should see them go to ground. That's critical. They should go to ground alternately. If you don't, if one of the channels stays at battery voltage and doesn't get pulled down to ground, i.e. no current flow, then you've got a broken wire. And you know which wire is broken because, well, you can look at your little crib sheet like I've got, look. See, channel 1, white plus blue, channel 2, green plus red, channel 3, pink plus black, channel 4, blue plus pink. If, however, you've got no voltage on 2 of the windings, and there would obviously be a pair, so let's say there was both the red and the blue were stayed at 0 volts, then it could be the fact that you've got a broken feed wire. One of the red plus black tracer wires is broken, and there's no power supply to that pair of windings. Now, since I've got a spare idle speed control valve off one of these bikes, I think what we should do is plug this in replacement to the one that's on the bike. We don't need to fit it to the throttle body because I want to show you what's actually happening visually at the idle speed control valve. And at the same time, I'll move the laptop across and we can capture the waveform. Hopefully this is going to work. I have no idea. Well, that wasn't too difficult. So we've got the replacement unknown idle speed control valve here, and this is the actual valve that controls the airflow, the bypassing airflow through the throttle body. If it increases the airflow, engine RPM goes up. If it decreases the airflow, engine RPM comes down. Pretty simple. Okay, now I'm going to start the scope. Dum dum dum. There we go. Oh, hang on, let's get rid of our little box. Hang on, we'll start again. Okay, stop. Start the scope. Turn on the ignition. Turn off the ignition. And stop the scope. Cool. Okay, let's head back to the bench and take a little look. Looking pretty good is that one. I might have to keep hold of it as a spare. One thing I did notice, which I'd like to bring to light, is if we look on channels 1 and 2, we've got what appears to be a missing pulse. Now, that's not actually the case. Well, it is the case, but what's happening here is the ECU is changing the direction of the idle speed control valve. Is it, you know, basically the valve was coming out, which was closing, reducing the airflow, and when you turn the ignition off, it resets the position of the valve, so the valve fully closes, i.e. it fully extends, it stops, then it comes back in a set amount ready for restarting the engine. And this is captured on the scope here, is the point where the armature changes direction. So if you see one of these pulses, you know, when you scope, it's not a fault. Obviously, if you see more than one, it is. It only happens on one pair of windings. It doesn't happen on the other pair, just for reference. Now, with this particular idle speed control valve system that's used on lots of different Japanese ATVs, obviously including Suzuki, it has the 6 wires, 2 positive feeds and 4 switched grounds, switched by the ECU in a specific sequence. There is no feedback to the ECU, so basically the ECU during that ignition off, ignition back on cycle, it works out what the minimum, the fully open positioning is of the idle speed control valve, and then it cycles the valve all the way until it's fully closed, and it's busy counting the number of actuations, the number of sort of pulses, the number of times it has to energize each of the windings in the stepper motor to get from one point to the other. And then it counts back so many. There's no feedback. So for example, if the valve gets jammed or it doesn't actually actuate, let's say it's got you know, a broken winding or something, or a broken wire in the loom, it'll still go through in its own mind that that sort of reset process each time you turn the ignition off, but it's not actually going to be moving the valve. So it doesn't know where the valve is. It might think that the valve is at 26% opening, and in reality it's stuck at 78% open. If that's the case, the engine's going to be revving its nuts off. The ECU is going to go, oh, the idle speed's too fast, I need to close the valve. So it'll actuate the valve an increment, say a percentage of closure, and it'll look at the engine RPM again. It'll go, oh, it's still too high. And it'll keep going through that process until it believes that the valve is in the fully closed position. Only once it reaches 0% opening will a fault code be flagged. Or, if the idle speed is too low, then it'll open the idle speed control valve 1% at a time until it hits 100% of opening, but the idle speed is still too low. You get my drift? That's basically what's going on. If there was a seventh wire and there was some way of providing a feedback, an actual position of the TPS, say a set, not the TPS, sorry, the idle speed control valve, there was actually a sensor in there, then it would be like a self-check, and the ECU would know straight away if its commanded requirement wasn't actually being fulfilled. But it doesn't have that. It has to wait until it reaches either 0% opening, i.e. fully closed, or 100% opening, i.e. fully open, before a fault code is flagged. It's really interesting. But to fully understand how the system works, that's how you're going to diagnose faults. Now, I've had a quick read through the Suzuki manual, and they state, come back to Live Laptop, they state that you can also do a really simple internal winding resistance check. Let's have a quick look in the manual and see what that value is, and then we'll test the one in the bench, because I believe that the manual is incorrect. So on page 1A-71, it gives us, just down here, look, on the bottom line, idle speed control valve resistance, approximately 31 kiloohms at 20 degrees C, so ambient temperature basically for New Zealand at the moment. Remember that number, 31 kiloohms. So very quickly I just want to do a quick diagram so you can see how we're going to test the resistance on this. We've got basically two pairs of windings. So if we come down here, we've got one winding and we've got another winding. And we've got another pair. And I'm going to put them bang opposite because, actually no, I'll do them on one side because it'll stay in camera shot then. So we've got one coming down here. And we've got the other winding here. Oh, open circuit, that's no good. And this is the 12 volts. We'll just put power in, positive, 12 volts, positive. Not that it makes any difference. Basically, we're going to check the resistance across these two wires. And then these two wires, so we'll call that A, call that B, across these two wires, C, and across these two, D. Now, of course, I could put all the colours of the wires in, but I think you get the idea. This one is red and black on the loom, as is this one as well. Whatever the other four colour wires are, they are the grounding sides of each of the windings. Okay, let's head over to the vise where I've got the spare idle speed control valve that I have, and let's measure that one, because we know the one on the bike is good to go. Not too sure about the one I found in the cupboard. Right, that sort of works, doesn't it? Trying to get everything in one camera shot for you. So we know that where's my probe? We know that the center two terminals, that one there, and this one here, well, they're the centers of the windings. And then, of course, one winding goes across to this terminal, and the other winding goes across to this terminal. And the same on this side, from this one to here, and this one to here. So, if I get my little crocodile clip, stick him on there, look, make sure he's not going to contact anything else, and we're going to move the meter. What was the scale? 31 kiloohms, so we need to be on the 200 kiloohm scale. Right, so I can put one of my leads onto the crocodile clip. There we go, look, it's on. believe me. And just holding that one out of the way. Now, if I go on to there, what have we got? 0. That's not right. Okay, it's not measuring what we want, so we'll go on to the other one. Oh, yeah. Yes, they're not touching, don't worry. 0 again. Right, let's try these other two. 0 and 0. Right. Let's go down to 200 ohms. I think they made a mistake. It shouldn't have the kilo ohms. It should just be 31 ohms. So we're on the 200 ohm scale. And since we're on this side, we'll test this side first. We've got known good 29.76. Well, we think it's a known good, don't we? Okay, round to this side. Yeah, pretty much the same, 29.8. And switch our crocodile clip across onto that one, 29.8, 7. And the last one is same again, 29.8. So, highly unlikely that all 4 of these windings are out of spec and they're all the same. Bizarre, isn't it? But mistakes do happen. Save the batteries. Okay, I can hear you saying, Andy, that one in the cupboard might be faulty. You're right, it might be faulty. Highly unlikely that all 4 windings are out of spec, like I said, but all the same resistance value. But just to put your minds at rest, I'm going to pull the one out of the bike. We'll test it in exactly the same way and see what the resistance values are on that one. I know both these two components are the same part number, so they should be the same. Let's find out. Right, pretty much finished scoping now, so we can probably get rid of all the leads, but I'll leave them in for now because I might decide to do a bit more off camera later on. Okay, Mr. Throttle Body. Removing these is dead easy, but you've got to dig your way in first. Right, don't lose the screws, Andy. Jeez, I do have some spare ones somewhere there. Okay, 2. I'm filming this bit to prove that I'm taking it out of the throttle body. Right, 3. Jeez, that one was tight. There we go. Now I have put covers over the intake as well on the engine, just in case I drop stuff and dust and stuff. Right, okay. There we go. We have the prize. Let's go and check this one out. Okay, so as the manual says, it should be 31 kilo ohms. Kilo ohms. Yes. Okay, put that on there. Could be wrong. Pretty sure I'm right. Stick that on there. Right, we are on the earth. The ground side is done of the probes. I say ground side, it's not really a ground side, it's just the negative, the common. There you go. Right, so we're going to test that one. Oh. 0. Test that one. My sincere apologies. For some reason, the camera stopped working. It tried to do an update. So we'll test his friend again. 0. Okay. Onto the opposite pair of windings. Again, 0 and 0. Okay, let's stick it down to 200, assuming it should be 31 ohms as opposed to 31 kilo ohms. Testing this one first. 29.9. That one. 30. Cool. Move the common across, black, whatever you want to call it. It's the other probe. 30.1 onto that one. 30.2. Cool. So known good spec, 31 ohms or thereabouts. There we go. Right, so that brings us to the end of the video. We've done heaps of stuff, to be fair. We've done where is the idle speed control on the bike. Well, you know that now, it's on the throttle body. On these Suzukis, you know how to get there because I've pulled all the panels off so you can see. We've looked at a wiring diagram so you can see how the whole thing's wired up. The 6 different wires. It's got 2 power feeds and 4 grounded wires grounded by the ECU. And those grounding wires, incidentally, run only between the idle speed control valve and the ECU. They don't go anywhere else on the bike. So, if you suspect a broken wire, you can unplug the ECU, you can unplug the idle speed control valve, you can put 12 volts on one end of the wire, and you can put, let's say, a 55 watt bulb on the other and then ground it. And then give the wire a wiggle. And if the light flickers, or it doesn't light up, or it flickers, or it's dim, or whatever, you know you've got a problem with that wire. And you can do that for each of the 4 wires. Just make damn sure you've unplugged the ECU first, and of course the idle speed control valve. But testing wires under load for breakage is a far, far better way of doing it. It's more conclusive than just doing oh yeah, I'm getting 12 volts, she's all good, with a multimeter. That's not conclusive. You only need one single strand of wire to give you your 12 volts. That sure as hell won't carry the current, Anyway, hopefully you've enjoyed this video. We've used the PicoScope, we've done some resistance checking, we've found a problem with the service manual. It's not 31 kilo ohms, it's 31 ohms resistance value. So there's got to be some value in that as well, hasn't there? I enjoy this kind of stuff. It's a Saturday afternoon, not much else to do. Got to get back on with the CB750 though. It's looking nearly done. It is. If you enjoyed the video, why not click on the subscribe button. Also ring the bell, you won't miss out on any future videos. If a couple of weeks go by and there's no videos go up, don't panic. It's probably because I'm out on the road doing my day job. I can't film in the workshop when I'm maybe 3,000 or 4,000 kilometers away. There's an archive of videos. There's about 550, probably more than that now actually, maybe 580 videos already on the channel. Dig deep into the archives, you'll find all sorts of stuff on fixing motorcycles, ATVs, side-by-sides, bit of welding, bit of fabrication work. There's all sorts of stuff on there. It's great fun. Oh, and by the way, some of the videos I have assistants on as well. You'll have seen them in the trailer at the start of this video, and no doubt you'll see a few more in the credits. What else? You'll find me on Facebook, Instagram and Twitter. Feel free to communicate through those portals if you like. You can also email me directly. My email address is down the bottom in the description. And just before I sign off, all the PicoScope files that I've got that we've taken during this particular video, I will stick into a Google Drive, and I'll put you a link in the description as well. And don't panic if you haven't got a PicoScope. You don't need one. You can go onto the Pico Technologies website, and you can download a demo version of their software free of charge. They do support the channel. God, disclose that. They do support the channel. And you can then load in those files and take a look for yourself and do some measurements and have a play around. It's a really good sort of sandpit to have fun with and just get to grips using a scope, basically. They're very cool. Now, lastly, if you want to support the channel, you can do that through Patreon. You can become a patron to the channel. There's a link on the homepage. And you can also, if you wish, use PayPal to do a direct payment. And it's the same email address, andymechanic@live.co.uk. Okay, crew, until next time, see you around. Cheers, over and out.
And you get the flip up again.
Oh!
Really.